So you just got some contract work with an e-commerce company based in New York City that sells clothing online, but they also have in-store style and clothing advice sessions. Customers come into the store, have sessions, meetings with a personal stylist. Then they go to home and order the product on the mobile phone or on their website. The company is trying to decide if to focus their efforts on their mobile app experience or their website. So they have limited funding and they want to know if they need to invest on mobile app or on the website. They hire you to help them figure this out. So what are we going to do first? I want you to import pandas as PD, import numpy as NP, import matplotlib.pyplot as PLT, import Seaborn as SNS. And as you remember, these libraries, for example, NumPy and Panda, are a powerful data manipulation and analysis library in Python. For NumPy, it's fundamental package for scientific computing in Python. Matplotlib.pyplot is a collection of functions within the Matplotlib library that makes plotting easier. And Seaborn is Python visualization library based on Matplotlib. Okay, so let us run these codes. Let me go back to the Jupyter notebook. And give you the codes that you need. So the data that we have are called e-commerce customers. I wanted to set customers to be pd.read_CSV, open close parentheses, and put e-commerce customers into double quotes. This is not a CSV file, everybody. After doing that, we want to take a look at some of the data in our collection. We have the email address of people, their address, the avatar, the session length, time on app, time on website, length of membership, yearly amount spent. So we're looking at a couple of information, a few information in our data set. The function .head, open close parentheses, typically displays the first few rows of the data frame in Python. So it gives us a few information of what's going on in our data set. Next, we're going to take a look at the statistics. What is the mean? What is the standard deviation? What's the count, the minimum value, the first quartile, second quartile, and the rest of the information in a statistical point of view. Please make sure to run customers.describe, open close parentheses. Count, the mean, standard deviation, and so on. So of course, it doesn't provide any information about the address and the avatar. Those are not numerical value. We expect that. As you remember, .describe, open close parentheses would give you a summary statistic of numerical columns in your data frame. Next, let's get some information. .info, open close parentheses would provide you with a concise summary of data frame. It includes information about the index data type and column data type, non-null values, and memory usage as well. In the next step, we have a line of code, SNS.set palette GNBU_D. What is this? SNS.set_palette GNBU_D. This command sets the color palette to this specific color, which is predefined color pattern in Seaborn. The _D suffix indicates that it's dark version of GNBU palette. Then SNS.set_style white grid. Well, this command sets the plotting style to white grid. Seaborn provides several predefined styles for plots. You can go back and forth between different plots. Now, I want you to use SNS.joint_plot and set X to be time on the website, Y to be yearly amount spent, and your data is just customers. SNS.joint_plot is a Seaborn function used to create a joint plot, which combines the scatter plots for two variables along with their individual univariate distributions. This is the expected graph that you're going to see in your Jupyter Notebook or Google Colab or any other IDE that you're using. So here we go. Let me share the code with you so you can run this and visualize the graph on your end. The time on the website on the horizontal line and yearly amount spent on the vertical line. I want you to also create a joint plot, X to be the time on the app and yearly amount spent. So we want to compare these. We want to see what's going on. We want to get as much of information as we can by looking at the visualization, right? So which ones are more clustered? Time on the app, 12, and then between maybe 10 to 14, and the yearly spend can be about 400 to 600, we can say. But if you look at the previous graph, what do we see here? We have a lot of noise, right? 35 to 39, and it's a little bit difficult to fit a nice regression line here, right? You have a lot of noise. Perfect. So here we go. Let me make sure you have the code. Beautiful. So these are just visualization, right? Next, I want you to create joint plot. X is time on the app, the length of membership, all right? So again, SNS.joint plot is also a Seaborn function used to create joint plot, but with different visualization style. So if you run this piece of code, what do we see? SNS joint plot will create a hex bin plot with time on app on the x-axis, the length of membership on the y-axis, and hexagonal bins representing the density of points in the joint distribution of these two variables. So which visualization you like to see? Do you like these hexagons or the previous one? Which one is more convenient for you? Yes, definitely. Let me go back here and paste the code for you in the chat so you have access to everything. Here we go. It's easier for you to see. Yes, that's why we have different visualization. Thank you, Joshua. Very good. So what if you want to have a bunch of graphs visualizing these relations, all right? Is there any way, just one piece of code that creates all of these visualizations, relations between variables for us? If you run SNS.pairplot for the customers, it gives you all sorts of graphs connecting variables together. Makes your life much more easier. So here we go. It takes a little bit of time, just give it time. We created a bunch of graphs for you. Very good. The length of membership, average session length, time on the app, time on the website, and these are your x-axis. Average session length, yearly amount spent, time on the app, yearly amount spent, time on the website, yearly amount spent, length of membership, and then yearly amount spent, and so on. So now you have all sorts of visualization just typing one line of code. Very good, excellent. So these are just visualization. We need some numerical values as well. Before jumping to numerical values, let's take a look at the length of membership and yearly amount spent. The length of membership and yearly amount spent, it looks like you have a nice linear regression, and it is an increasing line. As the length of membership increase, we see an increase in yearly amount spent. Implot function not only creates a scatter plot of the specified variables, but also fits a linear regression model to the data and plot the resulting regression line for you. So if you want to see a regression line and a scatter plot at the same time, you can use this line of code. Very good. So let's go back here. And let me share the line of code with you. Here we go. And then let us split the data so we can fit the linear regression model and then analyze the performance of our algorithm. So now that we explored the data a bit, let's go ahead and split the data into training and testing data sets. Set Y to be customers, yearly amount spent. Set X to be customers, average session length, comma, time on the app, comma, time on website, comma, length of membership. And from scikit-learn, sklearn.model_selection, import train_test underscore split. And as you remember, this guy is a machine learning library in Python, and train underscore test underscore split is a function from model underscore selection module in scikit-learn that's used to split data set into random train and test subsets. Then set xtrain, xtest, ytrain, ytest to be train underscore test underscore split xy, and let us set the test size to be now 30%. Let me share the code with you so you can run this as well. I'm just running every line of code that I have. So as you can see, domain expert and have some basic knowledge is important in data science job. Which variables, which predictors to use, for example, average session length, time on app, time on website, length of membership. These are all important pieces of information that helps to make the prediction. Now let us train the model, everybody. From sklearn.linear underscore model import linear regression. And LM, set LM to be linear regression. Call your model LM. And LM fit x underscore train, y underscore train. Call lm.fit x train, y train. You're essentially telling the linear regression model to learn the relationship between the features x train and the target y train. It adjusts its internal parameters, which are the basic coefficients, to minimize the difference between the actual target values and the values predicted by the model, the residuals, everybody. After calling fit, the model is trained and ready to make predictions on new data. And then linear regression, copy underscore x, set it equal to true. Sometimes it helps, otherwise you can leave it as it is. Then print the coefficient. Let us go back to our Jupyter Notebook. We create an instance of a linear regression model. Oops, sorry. And then fit X train, Y train into this linear regression model. If you get an error, just run this line of code. And finally, print the coefficient for me. What are the coefficient in your linear regression? Then we're going to analyze if these are good or not. So the correlation coefficients, linear regression coefficients are 25.98, which is 26. Then you have 38.59, which is 39. Then you have 0.19. Am I right? Then you have 61.27, 28. These are the weight that you have for your variables, for your predictors. Remember that for a multilinear regression, you have y hat equals to a1 x1 plus a2 x2, a1 x1 plus a1 x2 plus a2 a3. These coefficients are weight basically that you calculated here. So you have multiple linear regression plus a and xn, and then you have b, which is basically the y-intercept. So these are the coefficients that you have: 26, 39, 0.19, 61.28. Okay. So let us do a little bit of predictions. Set predictions to be LM, which is the instance of your linear regression model, and that predict X test. The code predictions equal to lm.predict X test is used to make predictions on new data using the trained linear regression model. Remember that we already used those X and Y's to train the linear regression model. Now we're going to test it. You can also visualize this as well using a scatter plot. This is your Y test, the predicted Y. Looks pretty nice. Let us go back to our Jupyter notebook, give you the lines of code that you need. So you can do the visualization as well. But again, we need some numerical values to be able to, let me see, forgot to run these. From here, it doesn't recognize my line of code. Here we go. The Y test and predicted Y, they look nicely, right? But we need some numerical values, everybody. That's the important part. Now we're going to evaluate the model, right? Here we go. Let's evaluate our model performance by calculating the residual sum of squares and the explained variance score, or R squared. To calculate these metrics from sklearn, import metrics and print metrics that mean underscore absolute underscore error using your Y test and the predictions. MSE from metrics, you're using mean underscore squared underscore error, again using Y test and the predictions. And finally, RMSE that we introduce, NP.square, open parenthesis, metrics dot mean underscore square underscore error, Y test, and predictions. Remember that we just need to take the square root. So that's why we use numpy.square root. Perfect. So these are the numbers that we are getting, all right? Let us go back to our Jupyter notebook and type these in the chat so you can run this. Yes, perfect. Should get the exact same numbers. You can also visualize the residuals, everybody. So here, let us run this line of code for you. Let me go back to my Jupyter notebook. We want to take a look at the histogram of residuals and make sure it looks normal. So please run the line of code. So it's important for us to see a normality in the residuals as well. If you run this code, okay, just take time. Then here you have yearly amount spent and the density. You basically can see the residuals is basically normal, which is a good thing, everyone, which is a great thing. Okay. But is this a good model or not? If you take a look at the coefficients, these are the coefficients that you have. How can you interpret these coefficients, everybody? Holding all other features fixed, a 1 unit increase in average session length is associated with an increase of 25.98 total dollars spent. So this is the meaning of the average session length coefficient. Holding all other features fixed, a 1 unit increase in time on app is associated with an increase of 38.59 total dollars spent. This is time on app, and this is the coefficient that you calculated. Third one, holding all features fixed, a 1 unit increase in time on website is associated to increase of 0.19 total dollars spent. This is this guy here. And holding all other features fixed, a 1 unit increase in length of membership is associated with an increase of 61.27 total dollars spent. So do you think the company should focus more on their mobile app or on their website? They didn't ask about the length of membership. What is the correct answer? What is your suggestion to the financial team over there? What do you think? Please write your answers in the chat for me.